What is measurement and verification? Measurement and verification, as defined by the Efficiency Evaluation Organization, is the process of planning, measuring, collecting, and analyzing data for the purpose of verifying and reporting energy savings within an individual facility resulting from the implementation of energy conservation measures. The energy conservation measurements means all actions are taken to use energy as efficiently as possible to achieve a specified results. Examples are envelope building refurbishment, modification of mechanical control system setup, replacement of generators, and so on. The International Performance Measurement and Verification Protocol provides the framework and standard for the measurement and verification plan. More information is available in the website in the bottom. Measurement and verification techniques can be used by facility owners, energy managers, and energy investors for different purposes, such as increase energy savings. In this case, the application of measurement and verification allows to accurately determine the energy savings achievable after the application of an energy conservation measure. Improve engineering design and facility operation and maintenance. It means if the measurement and verification plan is included in the design process, it helps manager or maintainers to reduce maintenance costs and run facilities more effectively. Measurement and verification helps to document financial transactions. Indeed, in some projects in which the energy savings are the basis for the financial payments, a measurement and verification plan can clearly document performance in a transparent manner. It also enhances financing for efficiency projects and enhances the value of emission reduction credits. The measurement and verification follows 6 key principles. It must be as accurate as possible to justify its cost. An important point is the budget available to generate the measurement and verification plan. The cost of the latter should be lower than the economic savings achievable. Complete. The reporting of energy saving should consider all effects of a project. It measures only the significant ones and estimates the other. Conservative. Measurement and verification calculates savings such that they are not overestimated. The reporting of a project's energy performance should be consistent and comparable across different types of energy efficiency projects or different periods of time for the same projects. The measurement and verification must be relevant. The determination of savings should be based on current measurements and information where the project is used. Last but not least, all measurement and verification activities should be clearly documented and fully disclosed. A key point of the measurement and verification plan is the calculation of the energy savings after the application of an energy conservation measure. Energy savings cannot be directly measured but can be determined comparing measured consumption before and after the application of an action. As shown in the equation, savings are calculated as difference between baseline period and reporting period, plus-minus adjustments. But what are the baseline, reporting, and adjusted periods? The baseline is a period of time before the application of the energy conservation measure, in which the system behaves in the usual way. The collecting data not only refers to the energy consumption or demand, but also to independent variables which change on a regular basis and have a direct effect on the baseline energy use. Examples are weather condition and occupancy. The reporting period is a period of time chosen to verify the savings achieved after the implementation of the energy conservation measure. During this period, energy consumption or demand as well as independent variables is also measured. The adjusted baseline period represents the estimation of the energy consumption or demand that would have occurred if no energy conservation measure had been applied on the system. It is determined by adjusting the developed baseline energy model with data for independent variables collected during the reporting period. As you can imagine, to calculate the energy savings, it is necessary to identify an energy model of the system based on data gathered during the baseline period. This model describes the relationship between baseline energy use and independent variables. In the reporting period, the model is used to calculate the adjusted baseline energy. Now, let's show an example of application of energy saving calculation in a building that needs to be refurbished due to the high energy consumption. The action taken are the installation of external insulation of facade, replacement of windows, and replacement of heating generator. To apply the measurement and verification procedures, it is necessary to monitor the building performance. In this case, the building has been monitored for 1 year before and after the retrofit. In the following table, the monitoring data of the energy consumption during the baseline reporting period together with the degree days as shown. Degree days are measures of how cold or warm a location is. In the 2018, the overall energy consumption of the building was about 15,000 kWh, whereas on 2019 the energy consumption was about 9,000 kWh. A spontaneous stuff is to calculate the energy savings as difference between the energy consumption of 2018 and 2019. In this way, the savings value is almost 40%. This operation is wrong and provides a wrong assessment of the savings. To calculate the real savings, it is necessary to take into account independent variables as the degree days. In this case, a Symbols models can be generated using a linear regression. The result is an equation that correlates the energy consumption of 2018 with degree days in the same year. The adjusted baseline period can be now calculated using the model equation with the value of degree days of 2019. The result is an estimation of the energy consumption that would have occurred if no improvements action had been applied on the building. Now it's possible to calculate the real savings achieved. The green area in the graph is the real energy saved obtained applying the energy conservation measure defined before. The value is almost 60% and not 40% as calculated without considering the effects of the independent variables. The measurement and verification plan is a process that considers several aspects not treated in the short introduction. More information and knowledge can be obtained in the following sources. The reference is the EVO website, in which after a free registration is possible to download manuals regarding the measurement and verification process.